Okay. So, hello, I am Aarush, and I've been working at Dialog for over a year now. And my main focus at Dialog is testing, and it's my first time presenting at a user meeting. So let's see how it goes. So what's coming up is a testing framework called ullu. So what is ullu? How has Dialog been tested so far? Why and how ullu was created, and its future. So what is ullu? Ullu is a new testing framework that is supposed to have comprehensive coverage for all old and new Dialog APL features. I'll first start with the old testing of Dialog APL. So let's put this aside for a second. And so pre-Ulu, we had a lot of QAs going on at Dialog. We run them overnight. There's some QAs that run every week. There's some QAs that we run sometimes once a month. So there's standard QAs. Standard QAs test the interpreter in and out. They test all of the language features, how the language works. And then we have shuffle QAs. Shuffle QAs is pretty interesting. So how it works is there's standard QAs. These standard QAs, every time they hit a get space function, get space is a reference to last year's Richard Smith's presentation about how pockets are restructured. So every time pockets are restructured, it shuffles the pockets. So all of these tests are run parallel, and so it takes a lot more time than the standard QAs, and it tests a lot more different situations. Then we have unit tests. So unit tests test specific features, specific lines of code, and we have them embedded in the C code of the interpreter. And there are short lines that test very specific small features, line by line. And then we have first tests. First tests use something called an American fuzzy lop, and what they do is they generate lots of data and test the interpreter on a variety of data. Then all of this gets combined into code coverage tests. So when all of these tests are run, all of the code that's being used is combined into a code coverage result, which I will be talking about later as well. So then, so you'll be shocked about this. So there's a lot of versions and platforms that Dialog APL supports. So currently we have 6.5 platforms that that Dialog APL is supported on. So that's Windows, Mac ARM, AIX, Raspberry Pi, Linux, and Linux ARM, which is currently under development. So that is 4 versions of Dialog APL that we currently support: 18.2, 19, 20, and 17.1. So 6.5 platforms, 32-bit, 64-bit, Classic, and Unicode. That makes up to about 63 versions of Dialog APL tested every day. So that was the old tests. So we have those tests were the infrastructure for those tests has been written 40 years ago, and it's been updated every now and then. Ulu comes in with a new approach that is structured for all of the QAs. What it does is we look at Dialog APL as a black box first, and then we test the primitives one by one, and we go into depth with each primitive and each and everything that it can do, including edge cases and everything. So it is fresh eyes to the old testing of the new Dialog APL. So what does it do? So we start with verifying fundamental scenarios and correct results of the basic functionality of the primitives. Then we test edge cases. Then we go off to test all of the data types possible, and it is reproducible and truly randomized. Not truly, but as much as we can. So, and then in the end, we finally inspect code coverage and find out missing test cases. And I work with the developers very closely on how the code was written, what the developer thinks about the edge cases, what I think about the edge cases should be. And it's a comprehensive test for all of Dialog APL. I like to call it something like battle testing, where it's very close to the interpreter and it's trying to get it to do everything it can. So as of September 1st, 2024, we have 11 primitives that are covered, and There's comprehensive coverage, including all edge cases. There's 100% code, close to 100% code coverage for all of the primitives, and you can have a look at the primitives. Then, so we have a lot of primitives in mind. The goal is to cover all of the primitives that are there. So these are the next up: greater than, less than, exponential, grade, not equal, not, and union that are going to be next up in the next few months. So the process of testing, how do we look at it? So we look at fundamental scenarios. I will cover fundamental scenarios in my next slide. Then, so fundamental scenarios are general test cases that are known to everybody that this primitive can do certain things that are very fundamental to the primitive. Then we explore the code base. So while writing the fundamental scenarios, we don't look at how the code was written, and we treat it as a black box so that we can think as a developer, as an APL developer rather than an interpreter developer, and what an APL developer would do. Then after that, when we are satisfied with this is everything I can think of as an APL developer to look at it, then we explore the code base and see what the C developer thinks that how it was implemented. And we find cases that were optimized for some specific case, and then we explore the code base, check how it was written, then we check for code coverage. So whatever was written and whatever I could find that was missing, and we find what is actually missing, and if there's any if statements that have very specific cases that go on. So that comes under code coverage. I'll be talking more about code coverage later as well. Then we check user issues. So the issues that have been in the primitives and the users have reported them, we check if we have specific tests for that or not. Then we verify interpreter limits, and so we check if all of the limits of the interpreter that we have set and that exist are compliant by the primitives. John will be talking about this later today. Then we check for displayed errors. So everything is working. When everything is not working, it should also be correct. So we check for all the displayed errors. We check for if the DMX message is right or not, if the DMX error is right or not. Then we remove dead code. So there's a lot of code that might have been optimized now and that does not come through the code coverage anymore. So we remove all the existing code that is not being used anymore. So how it works is we have model functions. These model functions imitate what the primitive is supposed to do without using that specific primitive. So a very basic one would be addition. Addition is the subtraction with a negation of the right argument. So that's a very basic one. Unique is slightly more complicated. Magnitude is fairly simple but still complicated. And so we have these model functions that we use to imitate what the function does so that we can test on every possible thing that the function can do with a standard approach. And with the model functions, we also have to make sure that we're using a lot of primitives there, and there's no primitives that depend on the other primitive. So there could be a dependency loop with the primitives as well. So we have to look for that. Now, how the tests look like. This is a very small snippet from the test lines and very specific tests. So I use two functions for testing generally. One is assert, one is run variations. Assert is fairly simple. It has a statement that returns a Boolean and it reports to the main framework that what the result is. So this is a very simple fundamental scenario for unique, that the length of the unique data should be less than or equal to the length of the data. So that's a fairly simple scenario that should always exist. Then we have something for addition that's also a fundamental scenario where data plus data should be 2 times of data. That's pretty simple. Then we have magnitude. So magnitude uses a model for this. So we have data that we put in there and we evaluate it with the model of magnitude that was there in the previous slide. So this data, it consists of all of the data types that exist in Dyalog APL, and it is also modified, which I'll talk about later. So there's fixed data that we use for the initial tests that consist of all of the data types. So then we have run variations. So run variations works a little differently than assert, and it uses assert under all of these headings. So it starts with a normal array that I described. This can be of one or two data types mixed. Then after that, we take out a scalar component from that array. This is randomized, a randomized scalar component from that array, and test on that. Then we make an empty array out of the data provided and test the same test case on that. Then we have a differently shaped array where we apply a randomized shape function to generate different shapes with every test. And this is tested for all of the tests that use run variations. That is almost most of the tests. Then we test with the model. So like tests over here don't use the model and use the specific function that is predictive. So we put that data also through the model and test if it is right. Then after that, what we do is we pick up the data type of the array that's there in the standard data. We change all of its components to a truly randomized array of the same data type. So the data type is constant, but the numbers in that predictive data are randomized, and all of the data types are basically randomized. So it's the most data that we can get. And because there's random data and it runs overnight, so eventually we'll be able to test a lot of data points. So data, more data, and results. So ullu currently has close to 85,000 tests that it encompasses for the 11 primitives. Lots of numbers, lots of arrays, lots of data elements, a lot of data. And good news is ullu is now integrated with the standard and coverage QAs of Dyalog APL, and it runs overnight with all of the test suite. This is what the code coverage looks like. So I get a report with the file name, and it points to function coverage, line coverage, region coverage, and branch coverage. So some of the files you can see have 100% coverage, close to 100, close to 100. So function coverage is if all of the functions that are there in the file are covered. Line coverage is if every single line in the file is covered. And region coverage is every single region meaning all of the if cases, all of the switch cases, all of the for loops are covered. And we have branch coverage that also deals with if-else statements and branches in code. And inside a file, it looks like this. So this column tells me how many times this particular line was run. So case 3 was run 14 times, and the line inside of case 3 was also run 14 times here. And the switch was switched on 16 times, and case 1 was not hit at all. And case 2 and case 3 have certain blue segments, which tells us if this is a if statement, and if that statement was run and the line inside it was run as well. So there can be a discrepancy if the line gets rejected by the if statement, so it will have a red in the bottom and a green at the top. So red lines are not run, blue lines are run. And white lines are also run, blue lines are run by if statements. So future plans. Okay, so the future plan is to cover all of the primitives that are there. It's gonna take a lot of time because we have a lot of primitives and there's a lot of coverage that we are working on. And work with more data. So right now our data points are a lot, but what is even enough data? We can have a lot of data because it's at our disposal. And we want to find cases that people might not even hit in 100 years with primitives that they don't use, or specific cases of primitives that one new developer that comes from a different language thinks how it's done. And we might not support that, or we might have not tested that. So it aims to find all of the possible cases. And the plan is to make Dyalog APL more reliable. So one more thing that we can do is with the data right now, one special thing about these tests is it takes around 2 minutes to run the QAs removing the slow QAs with a fast mode. And if you run it with the slow mode, it takes around 20 minutes compared to the standard Dyalog QAs that run for hours and hours. It runs close to 12 to 17 hours, and that's one thing that it is faster, and it's written in APL, so that's a good thing. So you can find out ullu at github.com/dialog/ullu, and you can also reach out to me if you have any questions at aarush@dialog. And ullu is completely open sourced, and anybody can come and contribute tests, give suggestions, and if they find a particular case, they can report it. And I will be happy to help and guide you with the technical demonstration as well of how it works and how it's done and how you can come and contribute to it. It has documentation about usage, about technical decisions. It has documentation about how to add tests, how to change tests. So I would be very happy if some people take a look at it and contribute to it as well. So in short, ullu is new, structured, independent, and a second coat of paint over the initial coat of paint with the old tests of Dyalog APL. The old tests are not going anywhere, and this is a second reinforcing coat of paint over the old tests. So it's going to be brighter and more reliable. So this also provides us logical and actual coverage over all of the tests. So I would like to conclude with something John said that day, that it is not just about finding things that are wrong with Dyalog APL, but making us more confident while making enhancements and making the developers more confident to explore.